Hi everybody, Ryan Jackson here. Hope you're doing well. We're going to talk about a couple of changes in the 2020 NEC to the working space requirements in section 110.26. It's kind of funny, but every time we adopt a new code, one of the questions that I get asked most often is, what's the biggest code change? Or what are some of the biggest code changes? And it's not something that you can really answer because it depends on what you do for a living. The answer is going to be very different if you're a residential electrician or you're an industrial electrician, if you work at a facility or if you install fiber optics. So it's a question that can never really be answered. But I'm going to cover a couple of changes that definitely could be the biggest changes depending on what part of the industry you're in. Now, today this is going to be strictly a discussion for commercial and industrial installations. So if you're a residential guy, I hope you'll stick around and watch and learn anyway. But really, the conversation is for commercial and industrial installations, and especially for design professionals and for facilities electricians. So we look at 110.26a. It says working space for equipment up to 1,000 volts to ground must comply with A1 through A4 if it's likely to require examination, adjustment, servicing, or maintenance while energized. Now, looking at this photograph, I think most people agree that a panel board meets that criteria. At some point, somebody is going to have to examine, adjust, service, or maintain that piece of equipment while it's energized, even if that is just a matter of verifying the presence or absence of voltage. Most people agree that panel boards, switchboards, switchgear, motor control centers, equipment like that needs to have full-blown working space. We can argue whether that's required for transformers or not, but really that is a matter of opinion. If you're the AHJ and you think transformers meet that criteria, then so be it. If you're an AHJ and you think they do not meet that criteria, that's okay too. Somebody has to make that determination. So A1 talks about the depth of the working space, and that's of course 3 foot or 3.5 or 4 feet, depending on voltage and conditions. And bear in mind, we're only going up to 1,000 volts today. A2 talks about the width of the working space, and that's the full width of the equipment, but never less than 30 inches. And then A3 talks about the height of the working space, and it says the working space extends from the grade, floor, or platform up to 6.5 feet, but never less than the actual height of the equipment. So in this photograph, we need to have 3 feet of depth, we need to have the full width of the equipment, and the full height of the equipment, because it appears the equipment is taller than 6.5 feet. So if you could visualize an empty refrigerator box, I need to be able to take a refrigerator box and stick it in front of the switchboard, and nothing can be in that area except for you, the electrician. The other thing that can be in there besides you, however, is other electrical equipment. Now, do me a favor and let's read this without the code change first. Electrical equipment can be above or below the equipment and protrude into the working space up to 6 inches. This is the reason that installing a wireway like this underneath the equipment is permitted. I can put electrical stuff below or above the other electrical equipment as long as it doesn't stick out more than 6 inches. And that makes sense. That's a very reasonable allowance, because when I'm working inside of a panel, I'm not going to be standing, with my nose right in there and my toes touching it. I'm going to be at least 6 inches away. So this seems like a nice allowance. The change here is that it's now including the supporting structure for the electrical equipment, like a concrete pad, or what we commonly call a housekeeping pad. So here we have a motor control center. I think most of us would agree that this requires working space because it's likely to require examination, adjustment, servicing, or maintenance while energized. And I have a housekeeping pad under it. This complies as long as the housekeeping pad is not more than 6 inches in depth. Now, we could argue that previous versions of the code did not allow housekeeping pads whatsoever. Or you could equally argue that previous versions of the code allowed housekeeping pads of any size. And the reason we could argue either way is because it simply was not addressed. And really, that's the worst thing that we can have in the code. As long as we know what the rules are, we can follow the rules and we can play the game. But if we don't know what the rules are, then we can't be expected to comply. So, can I have a housekeeping pad under the equipment? Yes. Absolutely, unequivocally, that question is answered in the 2020 code. How big can it be? Up to 6 inches. Personally, I love this change. I'm very, very glad to see this. Because an installation like this, I have a major problem with. I think this is the worst type of concrete pad that you could possibly have, where it's like 18 inches or something, something close to that. So the depth of the pad is going to be measured from the closed equipment. If I look at 110.26 A1, that's how we make the measurement. It's with the doors closed. So how would I solve this problem if this was a new installation? It's certainly a violation. How would I make it comply? Well, I would either have to cut it and make it not more than 6 inches, or I would have to extend it and make it the full working space, the full 3 feet in this application. So either way, that's how I would comply with this new rule. Looking at this installation, I was driving around and saw this and just had to jump out and take a picture of it because there's so many discussion points. Does this installation comply under the 2017 and previous versions of the code? Probably, but you could debate that. The first issue that comes to my mind is the maximum height of the circuit breaker, and that's 6'7". So we would have to make sure that we satisfy that. But as far as the working space does not have to be level. It doesn't have to be flat. There have been proposals to require that, but they're rejected because it would be impossible to do. So what about the concrete pad here? Does that stick out too far? Well, certainly under the 2020 code it does. We would have to either cut back that concrete pad, or we would have to move the switchboard closer to the edge of it. I think putting it out nearly flush would probably be the best solution. Looking at this installation here, I think the space in front of the switchboard definitely complies. We've got a housekeeping pad. It appears to be not more than 6 inches, so I think we're good there. As we go farther away, we find a panel board, and the concrete pad requirements would apply to it as well, but if you think about it, that's not the supporting structure. If you go back and read this again, electrical equipment and its supporting structure like a concrete pad. Okay, that concrete pad is a supporting structure. That concrete pad is a supporting structure. This concrete pad is a supporting structure for the switchboard, not for the panel board. So the depth of the concrete here would not necessarily matter because that's not the supporting structure. Now, for the transformer, that is the supporting structure. So now it's important that we get with our AHJ before we install this equipment, in fact, before we pour the concrete, and we ask the AHJ, do you think a transformer needs to comply with 110.26A3? Because some inspectors will say yes and others will say no, and the fact of the matter is it is up to them. This is an interpretive issue. So we want to find out for sure what the inspector is going to expect, hopefully at the design stage and worst case scenario before we pour the concrete. There were other changes made in 110.26C which are much more substantial, however, and those have to do with large equipment in 110.26C2. So the general statement here, and I think they put this in the code back in 1971, it says for large equipment which is 6 feet wide or more and 1200 amps or more, a 24-inch wide by 6.5 foot high or larger entrance/exit is required on each end of the working space if the equipment contains overcurrent devices, switching devices, or control devices, and again is over 6 foot wide and 1200 amps or more. So looking at this installation, what we are trying to avoid, let's assume that those pieces of switchgear are pushed up against the end of the wall. So as I run to here, I hit the wall, my nose is touching the wall, I look to my left, there's a switchgear, look to my right, there's a switchgear. That's a violation because I need to have an exit from the working space on each end. Now, all you have to do to comply with this requirement then would be to pull those pieces of switchgear back 2 feet away from the wall, and then we would comply. As I go to the end of the corridor, I look to my left, I look to my right, and there's no switchgear. Now here's where people make a mistake. It does not require a full-blown exit like an International Building Code Chapter 10 means of egress out of the room or out of the building. It simply says I need to be able to leave the working space, and that's all you have to have. So I go to the end of the corridor, I look to the left, and there's a brick wall. I look to the right, and it's a brick wall. That complies. I don't have to leave the room. I only need to leave the working space. And the working space ends at the end of the equipment. So in this photograph, as long as these pieces of gear are at least 2 feet away from the wall, I've met the requirement. Now again, that didn't change. That's been in the code for quite some time. Another example here. Here's my long switch gear. It's pretty obvious that I have an exit at the end down here, so I'm good. I would need another exit on the close end of the photograph unless I met the exceptions, and it looks like this probably does meet the exceptions, and we're not going to get into those. The other thing, though, is that now this rule comes into play if the equipment is the service disconnect, the service equipment, and the sum of the service disconnects is 1200 amps or more. All right, so I have my 2 independent pieces of switchboard. If those combined equal 1200 amps and it's 6 feet or more, then I would have to comply with this section. Now this installation as drawn complies. In fact, we could make this much worse and still comply. Let's imagine this wall extends all the way to the other wall here, all the way down. It would still comply, because as I'm looking at this equipment, if I turn to the left, I can escape into a 24-inch wide space. As I'm working on this equipment, I can turn to the right and escape into a 24-inch space, so I'm good. Now listen, there are better places to be if this equipment is blowing up. There are better places to be than down here in this corner. But there's a lot worse places to be, and that would be right in front of the equipment. All we're trying to do is get it so you're not in front of the equipment if something goes wrong. Now again, most of that didn't really change. The only change here is the service disconnect, 1200 amps, sum of the disconnects change. The big change is 110.26 C2. And I think in many applications, this change really increases worker safety and is a great change in most applications. In the photograph here, I think this is a prime example of this new rule working extremely well. It says, and let's make sure we're on the same page, we're still talking about large equipment. So 6 foot wide, 1200 amps or more. Open equipment doors must not impede access to or egress from the working space. Okay, so here I have a switchboard. It's 6 foot wide, and as I'm looking at the front of the switchboard, behind me is this wall, and the wall is 3.5 feet away from the switchboard. So I have my 3 foot or 3.5 or 4 foot of clearance. This complies with the 2017 code. Here's the problem. When I open up those 2 doors, and they're each a 36-inch leaf, the little thing drops down into the slot there, and now I'm in this little box, and if something were to go wrong in there, even if I have the PPE on, I'm in serious trouble. I can't escape through this little 6-inch opening here. And I'm not, I mean, really, I would have to bend down and try to play around with those little things, and you guys all know how easy that is sometimes. I mean, a lot of times you're in there for 5 minutes trying to open those things up. So I think in an installation like this change is fantastic and really increases safety for electrical workers, and I'm all about that. I think that's wonderful. Where this can get extremely difficult is when we have big installations. So this is an existing installation, so obviously we don't need to go back every 3 years and rip our buildings apart to comply with new requirements. I'm not saying that. But looking at this picture, never mind the housekeeping pad, if I'm behind this door back here, do these open doors obstruct my egress? Absolutely they do. No question whatsoever. That impedes my access and my egress. Now, one of the things that's incredibly difficult with this section is it doesn't give us like a value. Okay, it can't impede access to less than 24 inches of width or anything like that. It simply says open doors must not obstruct your egress. So right off the bat, if you wanted to take a literal approach to this requirement, you could never comply with this requirement ever in any installation as currently written, because any open door by definition impedes your egress. It does. If you have to move around any object, that is by definition an impediment to your egress. Now, that is not the intent. That's not how we want people to enforce it, but that is how it's written. So let's go back and put our kind of real world hat back on for a minute. Let's take a look at this installation. I have both doors open. Well, in fact, let's close the small doors. Let's close those small doors. Does that large door impede my egress? Absolutely. No question whatsoever, it impedes my egress. I have to move around it, that's an impediment. So I would have to move the equipment on the right. How far? I don't know. I really don't know. What if both doors are open a full 90 degrees? I would have to move them apart a pretty big distance before I could rightfully say that I'm no longer impeded in my egress. An installation like this is a good example. Here I've got this open equipment door. That is an impediment to my egress, no question. So this room right here, at least this portion of this room, would have to be at a minimum 2 feet bigger, but that's only with one door open. What if I have both doors across from each other open at the same time? The code does not give us relief for that. I would have to add at least, what, another 5 feet between these two pieces of equipment? And in this room, this is not the only little corridor of switchgear. This room would probably need to be, and I'm being serious, probably 30 feet bigger to satisfy this new requirement. That's a big change. You know, that's the kind of change as a design professional, that's one that you better be aware of, because that could be a major problem if it gets called in the field. Now again, I don't need to go through and retroactively comply with new codes. But what happens when I change a piece of equipment? Well, you change a piece of equipment, you have to comply with the new requirements. So same installation here. How much bigger would this have to be in order to comply? 5 feet at least, you know, probably more. I'm guessing 7 or 8 feet before I could comply with that. And even if you did make it 7 or 8 feet bigger, could you still argue that any open door is still impeding your egress? Yeah. Even if you made it 50 feet bigger, you could still say, hey, that door being open impedes my egress. So I think there's definitely room for improvement in the 2023. I've already submitted a proposal, but I don't have the answers to this. I really don't. I think we probably ought to have relief for supervised industrial locations with qualified persons. At the facility here where this photograph was taken, they take safety very, very seriously. And there is no way that they would have doors opposite each other open at the same time. There is no way they would do that. However, there's no exception for that in the 2020 NEC, and I think there probably needs to be in future versions of the code. So I think existing installations for replacements, we need some relief. I think supervised industrial locations, we need some relief. And I think we need some dimensions to tell us what exactly an impediment is. Is this impeding my egress? I wouldn't say so, but a dictionary might disagree. What about any of these little buckets? What if their doors are open 90 degrees? Does that impede my egress? Well, I turn and smack my face on the door. I guess it does. But how do you fix that? You can't. These things can't open 90 degrees, or excuse me, they can't open 180 degrees because there's equipment on them. So this is definitely a tough change. It has the potential of having some major ramifications. I never even thought about customer-owned substations. Now, again, we're talking 1,000 volts and less here, And most of this stuff here is over 1,000 volts. But this is at a facility where I consult, and they have a customer-owned substation. And can you see this little box right here? This is a shipping container, like a Connex box, and it's full of all sorts of electrical equipment. And they have a similar installation, like this, but to a much smaller scale inside that shipping container. In order to comply with this new rule, the shipping container would have to be bigger. Well, the size of a shipping container is pretty much chiseled in stone because you have to be able to transport them across the road. You can't make shipping, as far as I know, there's highway regulations that limit how big a shipping container can be. So you can't just make these things, 6 foot bigger than they already are, because then you can't transport them. Again, that's my understanding. I'm not a road, Department of Transportation guy, but I'll tell you right now, if you have to resort to dropping things like this into place with a helicopter instead of a semi truck, that's a big change. And I know there's a friend of mine that works at a chemical plant where they have several of these shipping containers at several of their facilities, and they are extremely concerned about this change. They're saying this change could add millions of dollars to the cost of some of their projects. So if you want to know what's the biggest change in the NEC, a lot of people will tell you that it's GFCIs and things. Well, GFCI changes are big, certainly, and they cost money. But there's not an installation in the world where we're adding $1 million worth of GFCIs. This change could actually cause millions of dollars to be spent on a project, depending on what it is. So there you go. Those are the changes in section 110.26. Again, I think they're both great as in terms of improving electrical safety, but I do think that the one about egress obstruction maybe has a little bit of work that needs to be done in the next version of the code. I would invite you, if you're a code guy, to really stretch your imagination and help the industry and figure out what can we do to make this a better rule, something that could be implemented more easily. Hope you guys have a great day. Thanks for hanging out with me. I hope you enjoyed it, and we'll see you next time.